all rows of a second table. So this is what we called as, guys, here. This is the execution process of all joins, and every join condition internally executed based on this rule. Okay, now, right? So now, okay, so this is one example, few examples. Okay, how it was going to be retrieving your data. Okay, in the same to same, next one, the next join is non-equi join. So guys, here non-equi join is a quite quite opposite of your quite opposite of your equi join, guys, here. Okay, and now how it was going to be defining here means non-equi join is used for, guys, to retrieve to retrieve data from multiple tables based on any condition based on any condition based on any condition except based on any condition except an equal operator condition, except an equal operator. Okay, so operator condition. So that means you can use any operator like less than, greater than, and operator, or operator, between operator, any kind of operators you can use in your non-equi joint statement, but don't use it what now equal operator. So except equal operator, you can use any of join or any kind of the condition you can write by using of any kind of operator, but don't use it your equal operator. Okay, no? So that is what we called as a non-equi. It's a quite opposite of a equi join. So because equi join, we are using only equal operator only supported there, equal operator. But non-equi join is except equal operator, any operator you can use. Okay, and let you see, guys, here small examples I will show you. Okay, now, right? So now some example you can see. The first example, okay, right? So now, guys, here are two samples examples I'm creating here, the sample tables now. So create table, test one, serial number, and the name. Okay, this is one table, guys. And in the same pattern, one more table I'm creating now, test number 2, serial number, and some salary. Okay, fine. After preparing the two tables here, test 1 and test 2 in our database MyDB 6 p.m. Okay, and later I'm inserting few records into these tables now. Okay, let you see. In test 1 table, okay, so I'm inserting some serial number, okay, and some name I will send it here. So like 20 Jones. So this is one small table, guys, here. And later test number 2, okay. Now this is test number 2. Okay, now right? So now serial number and salary. These are the uh, two records in my test2 table and two more records in my test1 table. Now, finally, these two tables I'm just calling now, guys, here. So test1 table and test number 2 table, and to executed this one. Okay, and now we can see it. So in these two tables, okay, so we have your data, and now on these two tables of data, now I'm using non-equijoint condition or non-equijoint statement I'm going to using now. So how I'm going to writing that example of this. So select a star from test1, okay, space t1. So your t1 is alias name. Either you want to create an alias name or not, that's your wish. Okay now, so your alias names are not mandatory to create. If you create, you can create, otherwise directly you can write it, no problem. Okay now, test2. And now in my where clause condition, whatever the condition I'm writing now, this condition should be right by using of any operator, by using of any operator, but don't use it equal operator. Okay now, so now I'm passing, for example, test1 dot serial number is greater than test2 dot serial number. Okay now, so that means in this condition, which operator I'm using here, greater than operator I'm using. Operators now. Okay now, right. We can see as per the non-equi joint condition, whatever the data is there, the data was retrieving from two tables now. So okay, so serial number 20 Jones and 10 25,000. Okay now, so this condition basis, your record will be satisfied here, and whatever the record is satisfied here, those records are joins together and displaying on the screen. Okay now, but how it was going to be, okay, executed this query means same as it is that yesterday how I was showing the based on the rule, same rule I just followed here. Okay now, and now I just come out to take this condition now, whatever the condition I was written. So this condition I will take it, guys, here. Okay, and now I will take here test1 table, test1 table serial number column, and here test2 table serial number column. Okay now, so because this column only I was taken in the condition part. Now, so we all of you know in test1 and test2, so serial number in the test1 1020 was there, and serial number 1030 was there in test2 table. So now those things I will take it here. So 10 10 20 and here 30, and in between what we are using in between means okay, we are using which symbol, guys, here, greater than. And now the same thing, guys, here, whatever the rule of joints is there, the rule I need to follow it here, the rule I need to follow it here. Okay, so the first rule is what now, a row in a table, a row in a table is comparing with whatever the condition is there, this condition will be comparing with all rows of a second table, with all rows of a second table. Okay, and let you see, guys, here now 10 was there here. Okay now, so 10 first row comparing with the 10. Okay, so now 10 greater than, here the symbol is what now, 10 greater than. So 10 greater than 10, condition true or false, guys? Come on, condition true or false, 10 greater than 10. 10 greater than 10, yeah, condition is false. Okay now, so false means I just leave it, this condition row, right, row, this condition row, I just leave it. Now next one is what now, 10 greater than 30, 10 greater than 30. So condition true or false? So here also condition false. So that means there is no row which was satisfied the given condition here. Okay now, in the same to same, the next row I'm going to take here. So 20. So next row, 20 is greater than 10. 20 is greater than 10. So now 20 is greater than 10. Condition true or false? Condition true or false? Yes, your condition is true. So condition true means then this row will be joins together. This row will be joins together. This row will be joins together. Okay, now it was joins together, and the data is what now? 20 and 10. So it will be joins together. Next, 20 is greater than 10. So 20 is greater than 30. So 20 is greater than 30. Condition true or false? Condition is false. Condition is false. So that means no joining here. So that means in this all rows comparisons, in this all rows comparisons, only one row is matching as per given condition. That matching row is what now? 2010. The matching row is what now? 2010. So this is only the row which was satisfied the given non-equi-join condition in the query. Okay, now so this is one example, okay, how it was going to be comparing and to finding non-equi-join condition here. Okay, now right, in the same to same, one more example you can see. Next example. So write a query, okay, to display employee, to display employee whose salary, whose salary is between, whose salary is between low salary and high salary, whose salary between low salary and high salary. So this is one more example. This is one more example. In one more example, what I'm asking guys here, okay, write a query to display employee whose salary is between low salary and high salary. That means which employee's salary between low and high, between low and high, those employees data I want to retrieve from the tables. Okay, now so the question understand all of you? Okay, so the question understand now? I want to display employees whose salary is between low and high salary, is between low and high salary. Okay, now right, and now let me see how to write for this non-equi join query. Let you come out. And before that, before you want to write that query, okay, first of all, the two tables I need to call it now. Okay, I'm calling the two tables now. So one table, okay, the table name is EMP, is a one table guys, and carefully observe in this table, EMP table. Now this is your complete table information guys. Okay, this is complete table information, and in this EMP table, how many number of employees are there? You can see total 15 employees details we stored. Total 15 employees details we store. Okay, na? Right. So now in this 15 employees, carefully if you want to identify guys, carefully if you want to identify which type of columns we have, it means we have a like column names are employee number, name, job, MGR, hire date, salary, commission, and department number. So these are our columns. But in this table, can you identify guys here, if is there any column like a low salary and a high salary? So the type of columns are there in this table. Low salary column or high salary columns are there. Okay, no. So there is no salary and low salary, high salary columns data is not there in this. So here we have only salary column. Here we have only salary column, but low salary, high salary columns are not there in this table. It means what you understand guys here, that low salary and high salaries informations are having in another table, having in another table. That another table I'm calling now. The next one more table is there na, second table. The second table I'm calling, that is called a select star from, okay, So S grade table is there, and now we can see only S grade table. Now we can see S grade table. In S grade table we have a grade numbers. So grade numbers means, like for example, serial numbers or whatever it is. Okay, and we have a low salary column and high salaries. So low salaries, if you see, 10,000, 15,000, 18,000, 24, 42, 57, 60, 74. So these are all are called low salaries, and these are called as the high salaries. Okay, now, so these are the two columns we have it here. So that means what it was happening, guys, here, employee details are having in one table, and low salary, high salaries informations are having in another table. Okay, now what we want to do, by taking off these two tables, which employee salary is between low salary and high salary. Okay, so here what I want to do, which employee, the total 15 employees are there now. So which employee salary, which employee salary, okay, which employee salary is between low salary and high salary. Okay, so like this, who are there in my EMP table, whose salary is low, whose salary is between low and high. So those people I want it, those people I want it. Okay, now see how to write that query, non-equijoin statement. Select star from EMP, next S grade, where employee salary, see I'm using here between operator, between, okay, low salary and high salary. Okay, now between low and high salary. So now here I will be take those columns here, employee name, salary, low salary, comma, high salary. Okay, few columns I was taken to easily understanding purpose. Okay, now this is your condition. But guys, you can see in this joint condition in my where class, I'm not using any equal operator. I'm not using any equal operator. Yes or no? So except equal operator, you can use any operator that I said, between and or, greater than, less than or equals to, greater than or equals to. So any kind of operator you can use, but don't use it equal operator. And in this example, I'm using which operator? Between operator and end operator combination I used here. Okay, now you can see, once I want to execute it here, once I want to execute it here, now we can see, guys, here total 15 employees are there in my table. How many employees are there in my table? 15 employees are there. But out of 15 employees, only few employees are satisfied my given condition. Only few employees are satisfied my given condition. Okay, now whatever the output was came, this output just observed. Okay, so now we can understand that whether these employee salaries are in between low and high or not. Okay, now we can see first employee Jones salary 15,000. Now tell me, guys, here this Jones employee 15,000 salary is comes between low salary and high salary. Satisfied? Huh? Come on, guys. Jones employee salary 15,000 is satisfied in between low and high salary. So your condition true or false? Okay, so this person is satisfied. So that means this person's salary was satisfied in between low and high salary. Okay, now right. And now next employee 10,000. So now 10,000 employee salary, you can see this 10,000 is comes between 10,000 to 15,000. Yes or no? It is also satisfied now. Yes, so it is also satisfied. Like this, every employee can see. Now Warner salary 22,000. So 22,000 comes between 18,000 into, or 18,000 to 24,000. So this person also satisfied. Like a 47, this person also satisfied. 42, this person is also satisfied. 74, this person is also satisfied. 64, this person is also satisfied. That means, so total 7 employees. The 7 employees' salaries are in between low salary and high salary. That means the remaining 8 employees' salaries are, because total 15 employees now. So 15 employees means out of 15, how many people satisfied here? 7 people. So that means remaining, how many people are there? 8 people are there. So that means remaining 8 people salaries are not having in between low and high. Not having in between low and high. Okay now, so this is what the between operator you can use. And same to same guys here, suppose if you want to write here, okay, if you want to write the same example, even though you can write in another manner also. So in place of between operator, in place of between operator, can I use like this guys? Can I use where salary is greater than or equals to low salary, end operator, salary is less than or equals to high salary. So in place of between operator, can I use like this? Can I use like this? Yes, so we can use it. So now, but in these examples also, in these conditions also, here which operator I'm using? Greater than or equals to. Here which operator I'm using? Less than or equals to. And which operator I'm using? End operator I'm using. But I'm not using any equal operator in these conditions also. So that's why this is also comes under non-equi join. Okay, now we can go to checkout here. Now we can go to checkout here. The same output. See, once I want executed here, how the output was came by using of between operator. Same output was came by using of your less than r equals to or greater than r equals to by using of end operator. The total 7 people, the 7 people are satisfied here. Their salaries are in between low and high. Okay now, so like this guys here in non-equi join, you can use okay, any operator you can use it, okay, but don't use a equal. Don't use a equal. So like this you can use a between, like this you can use a and, like this you can use a greater than or equals to, okay, anything you can use, but don't use a non what we can say equal operator. Okay now, so this type of nature is called as a non-equi nature. This kind of nature is called as a non-equi nature. Okay now, right? So this is equi and non-equi. So that means only the thing is what now? Equi join only supporting equal operator. Other than equal operator, you can't use it any other operator in equi join. Non-equi join is a quite opposite. Except equal operator, you can use any other operator. Yes or no? So this is non-equi and equi. Okay now, right? And the next operator in non and C is a very, very important operator that is called what now? Self-join. The next operator is very, very important in non and C, self-join. Okay, and now we can see, sir, what is self-join? And self-join, how it was working. Okay, now observe carefully. And this is very complicated join and also very important join in our joins concept. Okay, if you go to any interviews about a databases, maximum the people are going to be asking questions from self-join only. So equi join, non-equi join, inner join, outer join, these are simply they can understand. Anybody can understand simply because we have a conditions on two tables, retrieving the joining and retrieving the data. But self-join is not like that. Self-join is completely different. And in this self-join, there are more complexity also there. That means there is a more chances to have a confusion in this self-join. So that's why wherever the more complexity was there, the type of questions are coming out for your interviews. Okay, now we can see self-join, how many people are confused at the first level observed and how many people are understanding first level observed. Okay, but carefully check out guys each and every point. I will check it here, and each and every point I will slowly explaining now because it is a very important join and very confused and very complicated join. Okay, so please focus on this. Okay, right. First of all, the thing is we need to understand about self join. First, we have to know about what is the mean of self. Okay, what is the mean of self, guys? General word I'm asking. Generally, what is the mean by self? Self means Are you depending on any other, or else are you depending on yourself? What do you say? Self means, are you depending on others, or yourself you are depending? Yes. So depending on myself, that means self meaning is what now? What is the mean by self means? Self is nothing but depending on ours. That means we don't want to depending on any other person. We don't want to depending on second person. Okay, now we are depending on himself, she's depending on herself, or we are depending on ourselves, but we don't want to depend on second person. Okay, now so here also self join. Join is nothing but what now? Combining. Join is nothing but what now? Combining. Okay, now previously when you identify equi join and non equi join, we identify here in these two join statements. Whenever I want to write some query on equi and non-equi, here we are using two tables. We are using, yes or no? Yes or no? We are using two tables now in equi join and non-equi join. We are using how many tables, guys? Here we are using two tables. We are using, so two tables are using means, it means what now? Okay, is depending on DEPT, depending on course table. Otherwise, EMP table is depending on S grade table. Otherwise, test 1 table is depending on test 2 table. So that means equi-join example and in non-equi-join examples, if you see these two join mechanisms, I was applied on multiple tables. That means one to another table data comparisons, one to another table data verification, one to another table data dependency. Okay, now so that's why what we did in equi and non-equi, EMP table data we are comparing with the department table, student table data we are comparing with the course table, EMP table data we are comparing with the S grade table, test 1 table data comparing with the test 2 table. So that means one table data we are comparing with another table data. Those are what we done equi and non-equi. Okay, right? Now, so these are what now? Dependencies. It means EMP table depending on department, department table depending on EMP, test 1 table depending on test 2, test 2 table depending on test 1, students depending on courses, courses depending on students, like EMP depending on salary, salary grades depending on EMP. So that means here every table is a dependency to each other, dependency to each other. That's why the two tables data we are going to be comparing, and in this comparison, wherever your condition is true, wherever your condition is true, the true conditional rows, the true conditional rows data combining and retrieving from your tables. So that is what we done in equi join and what we done in non-equi join. Okay, now so I think all of you clear this, right? Now, but whereas come to self, yes, self means what we said here. We don't want to depending on second person. We don't want to depending on second person. I want to depending on myself. I want to depending on myself. That is called as self, we called. Okay. So that is the reason here EMP table data joining with the department table. Student table data joins with the course table. EMP table data joins with the S grade table. Test 1 table data joins with the test 2 table. That means one table data joining with another table data. One table data joining with another table data. Those are called as a equi, non-equi. Equi, non-equi. But here self, what it was telling here, self joining, that means, now tell me, now I want to join with myself now. Yes or no? I want to join with myself. That is called a self join. Okay na? So you want to join with yourself, but you don't want to join with others. Okay na? So that is you don't want to join with the others, you want to join with yourself. Okay, that means you don't depend on others, you want to depend on yourself. Okay na? You don't depend on others, you want to depend on yourself. Okay na? That is what we call a self mechanism. Here also, that's what it was happened in self join also. You're joining, careful observe the statement, joining a table data by itself is called as, definition understand, is called as self join. Okay na? So that means joining a table data by itself only. That means a table data is not joins with another table. A table data is not joins with another table. A table data is joining by itself only. Okay, so that means the statement, all of you understand the statement, guys? Joining a table data by itself. Understand the statement? Come on. Right. So joining a table data by itself. Okay, now? Right. So now tell me, guys, by taking of this statement, right? So now tell me, now self join can implementing on multiple tables or else on a single table. Tell me now. Now tell me, guys, by seeing of this definition, now tell me, how many tables can I implement in self join? One table or more than one table? Yes, very good. Good catching my point. Good catching my point, guys. Yes, it was working on only single table only. So that means a very, very, very important point is what now? Self mechanism, self join mechanism cannot be implemented multiple tables. So this is the one of the special and very important and very special join. Okay, so this join can be implemented on a single table only. So in this mechanism, there is a no chance to use a multiple tables. So multiple tables mechanism is not supported by self join. Self join always supporting single table operations only we can do. Okay, now that point will be confirmed by using of that statement, joining a table data by itself. Okay, now right. So now second point also clear, I think so. Okay, now all of you clear now second point also. Okay, right. So now here the point is what now, guys? Here, okay, the point is what now? Now we can see. Third point is what now? Careful observe. So self join can implementing on a single table only, we said. But guys, here the question is how a single table data is comparing by itself. How a single table data is comparing by itself. So this kind of question is coming out. Okay, now? Now I'm asking to you. Now tell me, guys. Suppose you want to compare by yourself. So what you want to do? Is there any logic? I want to compare by myself. You want to compare by yourself. So is there any logic? How to comparing by ourselves? Just think, logically think, logically think. So that means somebody saying that past tense and present tense somebody thinking. So that means old days and new days, present, previous, they are comparing like this. Okay, na? Before and after. Okay, fine. So now here the thing is, suppose I don't want to go for past present. So past present, what it is, I don't want it here. Now on the spot, in the present only, myself I need to check it. Myself I need to compare. Any idea? Yeah, for example, suppose you want to check yourself. You want to check yourself. So that means generally what it was happen, simple logic. You just go and stand in front of mirror. You just go and stand in front of mirror. What happened, guys? You can go and stand in front of mirror. What it was happen? Our image will be reflecting. Yes or no? Our image will be reflecting. So now I want to go stand in front of mirror. What it was happen? The same image, that means our same image will be reflecting to us. Okay, na? The same image is going to be reflecting to us. So now I can check myself now. When I stand in front of mirror, can I check myself? Can I check myself? Yes, of course. Of course, you can check yourself because you're standing in front of mirror. That means your image only reflected, and you are also checking with whom? Are you checking with your image only? Are you checking with your image only? You are not checking with the other image. You are not checking with the other image. You are checking with your image only. So that means what it was happening means whatever we are going to stand in front of mirror, the mirror outside image is called as a physical image. The mirror outside image is called as a physical image. And that physical image, are you checking with your virtual image? Yes or no? Are you checking with your virtual image? Yes or no? Okay. So that means what I'm saying here, this is one user. Now this user want to check himself or herself. Then what I'm going to say, now this user stand in front of mirror. Stand in front of mirror. Now this is we called as, okay, this is we called as mirror. And when you stand in front of mirror, the same image will be reflecting to us, reflecting to us, reflecting to us. Now this image is called as a, it is called as a physical image. And whatever we are seeing in the mirror, this mirror image is called as a virtual image. But what it was happening, guys, here, your physical image, are you checking with your virtual image only? So that means self checking. self-checking. Are you checking by yourself only? So how we can go to say, guys, here, the simple way. So this example why I was given, simply you can understanding purpose. Okay, simply you can understanding purpose. So when you have to go for, so that means one physical image comparing or checking with his own virtual image. This is called as a self-checking, self-comparison, self-checking we called. Okay now. So now how we can say this virtual image is required. Whenever I want to check myself, then compulsory I should create one virtual image on my physical image. I want to create one virtual image on my physical image. So when you create it like this, then only possible to comparing. Then only possible to comparing. Okay. So this is with the help of mirror, we did this one. With the help of mirror, we did this one. Okay, fine. So I think concept understand. Now here also, now a table joining or comparing or checking by itself. That means what we required here, here also we required to create a virtual table. Okay, here also we require what now? One virtual table is required here. So whenever you want to creating virtual tables, then only possible to implement a self-join mechanism. Without virtual tables, you cannot implement a self-join. You cannot implement a self-join. Okay, now see each and every point I was clearly explaining, guys, here, because it is a very important. That's a very slowly each and every point neatly I'm going to explain here, because you don't want to confuse. Okay now, right? So now what it was giving here, we required a virtual tables. Then how to create a virtual table on physical table? Okay, how I can, so generally on our physical body, if we want to create a virtual body, we are using some mirror help, some light help, some water help we are taking. Okay, some third party resource we are taking to creating virtuals. So here also I want to create a one virtual table on physical table. Okay, then how we can create means, yes, to create that kind of virtual tables, here what we required here, we required, okay, we and to implement self to implement a self join mechanism, we should we should we should create create what is now alias names. We should create alias names on a table. Alias names on a table. Okay, so the point is, without alias names, without alias names, we cannot implement we cannot implement self join. We cannot implement self join. Okay now, but here once you created alias name, internally what it was happening, okay, internally what it was happening, and how your virtual tables are created. Now let you see this point, very important point here. Okay now, so once we create alias name on table, internally SQL server is preparing SQL server is preparing a virtual copy, a virtual copy, preparing a copy table, copy table on on each on each alias name, on each alias name. So that means how many alias created on your table name, for every alias name purpose, internally your SQL server is preparing virtual copies on each alias name. Okay, now so like this we can create any number of we can create any number of alias names on a single table, alias names on a single table. Okay, now but every alias name should be should be different should be different. Okay, now suppose one of my table emp, so emp e1 one alias, emp e2 one alias, emp e3 one alias, emp e4 one alias. So like this you can create a number of aliases, but table is same, right? Table is same, emp table only. But on that same table, on that emp table, how many alias names I created, guys? Here, come on, how many aliases are created on this emp table? Yes, 4 aliases we created. 4 aliases we created. Okay, now so what it was happen here, you can create like this any number of aliases, but the thing is what now, every alias name should be different, e1, e2, e3, e4, but you can't create it like a e3, because duplicate alias names are not allowed. Duplicate alias names are not allowed. Okay, now so you should create every alias name with a different. Okay, if you're creating e3, it is showing error. So that's why every alias name is going to be different. It means what now, guys? Here it means what now? For example, one user is there, one user is there. Okay, this user or he was there, around him there are number of mirrors are there. Around him there are number of mirrors are there. Around him there are number of mirrors are there. So this is what now? Okay, this is what now? Mirror. So mirror 1. Okay, this is what now? Mirror number 2. This is what now? Mirror number 3. This is what now? Mirror number 4. Okay, now around him there are 4 mirrors are there. Then what it was happen, guys? Here, so this physical image body reflected how many? 4 times. So the in mirror 1, same image reflected in mirror 2, same image will be reflected in mirror number 4, 3, mirror 3, and same image reflected in mirror number 4. Person is same. Person is same. Person stand in front of or else around mirrors. Okay, then what happened? The same image, the same image will be reflected. So how many mirrors are there around him, that many virtual images are created. That many virtual images are created. But your person is only one person. Your person is only one person, but around him there are 4 mirrors are there. Then what happened here? 4 images are reflected. But it is not like that. If it is reflected 4 mirrors, 4 images reflected means it is not a 4 persons now. These are not a 4 persons, these are only one person. That one person image only 4 times reflected, because of reason 4 mirrors are there. I think concept understand now. Concept understand now? Yes. So now what happened? Whatever the mirror images are there, those are called a virtual images. And whatever the person is there around him or around the mirrors, whatever the person is standing here, that person is called physical. So that means on physical image, we are creating number of virtual copies. number of virtual copies were created. Okay, now so how it was going to be happening, same to same. Whenever you want to create, whenever you want to create alias name on a table, for every alias name purpose, internally one virtual copy table is prepared by SQL server. If you created 100 alias names on a table, 100 virtual copies are created. If you created a 200 tables, 200 alias names on a table, then 200 virtual copies are created. So like this, how many number of aliases are you created on a single table? Those many or that many, okay, virtual tables are created by SQL server internally. Okay, now, so with the help of these virtual tables, we are going to be comparing the data and checking. After that, we are going to be retrieving your necessary data from a single table. Okay, now, so this is self join, whatever the points I explained today. So these are we called as what now theory part. This is a theory, complete theory information I explained today. But practically how to do, okay, along with examples that we will discuss in tomorrow's session. So tomorrow I will go for, so practically how to do each and every pointer, practically how to do, okay, so that we will discuss in examples in tomorrow's session. Clear now, guys? The theory all of you clear now? The theory all of you clear now? Okay, right, guys. And now examples, okay, and practically how we can do that we will see in tomorrow. Okay, now so that's why tomorrow is very, very important concept, self join. Don't miss it. Okay, now we can understand the self join, how much complicatedly we understanding. Yes or no? So that's why I was showing some example diagrams also, because you can understanding purpose. Okay, and I'm slowly explaining this concept because it's a very important and very complicated, very confused topic this is. Okay, now so that's why don't miss it yesterday, sorry, tomorrow. If you miss now, then self join will not come back again. Okay, right, guys, thank you so much, and we will go for tomorrow.